The radius of an atom depends on the size of the charge of the nucleus, that is, the number of protons and the number of energy levels. Moving down a group, the radius increases as the number of energy levels increases. As the energy levels are being filled, that is, when you move across a period, the nuclear charge increases, which attracts the valence electrons close to the nucleus. This makes the atomic radius decrease. Also, valence electrons also experience a shielding effect caused by electrons in lower energy levels. The electrostatic force between the nucleus and the outermost electrons are much weaker as they have less of a force exerted on them. This makes the radius larger as more energy levels are added. Melting point refers to the amount of energy required to change any substance from a solid to a liquid. The attraction increases between these elements or compounds as you move across a period until group 14. Then it decreases. For example, covalent network substances such as diamond and silicon have very strong bonds holding their elements together, so naturally, huge amounts of energy or heat would be needed to weaken these attractions. Covalent molecules of nonmetals have low melting points, that is, very little energy is required to make them change from a solid to a liquid, so in terms of temperature, it would be super cold. If we take a gaseous metal, say M, it can lose an electron if energy is supplied that can overcome the electrostatic force between it and the nucleus. The energy required to remove the most loosely bound electron from a metal in the gaseous state is known as the first ionization energy and can be represented by the following equation. A second electron can be removed, but much more energy will be required. So what are the factors? The distance the electron is from the nucleus, as in the further out, the less ionization energy required. The presence of other inner shielding electrons, that is, the more shielding effect, the less ionization energy required. Charge of the nucleus, as in the greater the charge, the greater the ionization energy. And finally, the stability of filled or half-filled orbitals, as in it's difficult to lose electrons from these orbitals. By referring to these factors, ionization energy decreases as we go down a group, that is, less energy is required to remove the first valence electron, and going across a period, the ionization energy increases. This is because the electrons are going in the same energy level and are roughly the same distance from the nucleus. Electrostatic attraction increases with proton number, so these electrons are held tighter and require much more energy to be removed.